All right, this is a quick intro to dimensional analysis, measurement, and unit analysis. So we're going to call this part one. We'll do this in two videos just to kind of break it up. So some definitions just to get us started. All right, measurement is a number that describes the size or amount of something. So typical measures: length, area, volume, weight, temperature, time. Um, Something that we use all the time is data. So if you got a data package with your cell provider, or even home internets, typically you get a measurement in typically gigabits. All right. So, but now when we convert from one unit to another unit, some people call it unit analysis or dimensional analysis. All right. So those two terms are synonymous. All right, so these are just common factors. This is just a reference that you can use. I'm not going to walk through them. We'll use it once we hit the problems. Okay, so now the way the textbook presents this is they call it the factor label method. All right, so basically what you want to do is lay down your units as factors and then make sure you're canceling out the right units. Okay, so just don't multiply the numbers. Make sure that you're putting the units in the right place. And we'll start with this first simple example. All right, 3.5 feet. We want to go to inches. All right, so the first thing we're going to do is I'm going to go ahead and make that 3.5 feet a decimal. And I'm going to go ahead and put the units, feet. All right, so now with the factor label, we're going to go times. All right, so I like to go ahead and set my fraction up. I want to get rid of feet, so I'm going to put 1 foot as my denominator. And I'll come back and well, let's highlight it here. All right, so this is 1 foot. All right. So, and we know that 1 foot is 12 inches. So we'll go ahead and use our units. Now, the units you want to cancel should be on diagonals, okay? So here, the 1 foot and the 3 feet, okay? Don't let the terms throw you off. They're still same, just foot is plural, okay? They cancel. So take your calculator. You're going to end up in inches. You take 3.5, you multiply it by 12, which gives us 42 inches. All right, and let's go ahead and box it real smooth. Okay. All right, so next example. Now that's very simple. That's just to kind of show you the setup. Now, typically what you'll see is you'll see these word problems you have to dissect. Okay, but it's the same principle. Okay, so we've got a fence company that they're adding the fence to a rectangular area around this perimeter. Okay, the length. So I'm gonna go ahead and do my sketch. Boom. Okay, that's my rectangular area. All right, the length is 130 yards. So, okay, the width is 75 feet. All right, still no problem. All right, what is the total length? Now, the issue is, to find perimeter, you add up all the sides. But we have different sets of units. So what we're going to do now, notice they said, what is the total length? Okay. If they didn't specify yards or feet. So we're going to go ahead and do what's easy. I know that 1 yard is 3 feet. Okay. So I'm going to take this 75 feet. Go ahead and type it out. Times, I want to convert it to yards. Okay, so I'm going to go, now notice the 3 feet, they go at the bottom over this 1 yard. All right, let's highlight. All right, highlight the units that we know are going to cancel. Make sure they're on the diagonal, okay, because you're simply dividing by yourself. That's why. Okay, we're going to cancel out the feet. Now, the trick here is you can actually, let's use a little different color. treat that division line as if it's extended. Okay, so that's 75 times 1 yard. That's your numerator. So we're going to end up with 75 yards over 3. But that's not simplified. Go ahead and simplify it. Make your life easy. This is 25 yards. Okay. All right, so now what we're going to do, we're going to go back to our sketch. We're going to make this 75 feet, 25 yards. This other side, we're going to make 25 yards. Boom. All right, so, and we want to find the length of fence that we need. So we're going to add up all the sides. So that's 130 plus 130 plus 25 plus 25. That's 260 plus 50. And remember, all this is in yards. So this is 310 yards. Okay? So no problem. But now, if you go to a Lowe's, a Home Depot, or something like that, typically they won't sell it in yards, right? So you go ahead and convert it. So we're gonna go ahead and box that. All right. So if you're ordering online, typically they're gonna want to know how many feet. So no problem. We'll take that 310 yards. We'll multiply it by, we know that 1 yard is 3 feet. Okay. Yards cancel, so we need 930 feet. So now you got, and let's put an or. Okay. So either answer is correct. Okay. So you can always convert from, and it was actually better for us to go ahead and use the yards to initially do this, because if we was to try to convert that 130, we would have ended up with fractional answers, and it would have eventually worked out, but it was a little bit easier just to go ahead and use the yards to begin with. But either answer is correct. All right, so now we've got this example. A municipality or trash facility allows people to throw away, 30 pounds of trash per week. Okay. Last week, 140 people threw away the maximum allowable trash. How many tons of trash did this equal? So now we've got a couple different things that are going to happen. So let's highlight, or let's underline. We've got 140 people. We've got 30 pounds of trash. And then we want to know how many tons of trash. Okay, so I see pounds, tons, and I've got a set number of people. So let's do it this way. We've got 140 people. They each have 30 pounds of trash, and then let's say per week. Okay, and let's clean that up just a little bit. All right, times. Now we know that, again, if you don't know the conversions, it's in that table, maybe 3 or 4 slides back. So you can always pause or print out the notes and just have the conversions in front of you, or conversion factors in front of you. All right, we know that 2,000 pounds equals 1 ton. All right. Now, again, and this was 140 people. Okay, no worries. We don't have to cancel out the people, okay? But we need to cancel out these units. Pounds will cancel. All right. So now you take your calculator, and remember, all you have to do is take that 140 times the 30, and you're going to divide it by 2,000. Okay. And you're going to end up with a decimal answer, which is perfectly acceptable. Oops, back up. All right, so if I'm using my calculator, you can do this. You can actually type it just like this. If you want to be safe, you can put that numerator in parentheses. You don't have to, but that's just an extra step. You divide it out, you're going to end up with 2.1 tons of trash. Um, and then we're just going to say last week, okay? Just to give us some more context to our solution. All right, real straightforward, nothing hard about it. Just, but you can stack up these dimensions as far and as deep as you want to go. Okay. All right, and then we hit this point. All right, the post office charges 44 cents to mail something that weighs a single ounce or 1 ounce or less. The charge for each additional ounce or fraction of an ounce. Now that's important, okay? Fraction of an ounce, okay? If it's, it doesn't matter how much of that fraction is, but if it's a fraction of an ounce over that 1 ounce, you're going to be charged an additional 17 cents. And it says, at this rate, how much will it cost to mail a package that weighs 2 pounds, 3 ounces? Okay, so now notice the post office is charging by the ounce. Our package has pounds and ounces. So the first thing we're going to do, we're going to take those 2 pounds, right? And we're going to convert it to ounces. So 1 pound is 16 ounces. And these are dry ounces, okay? The pounds, they're going to cancel. All right, so that means this is 32 ounces plus the additional 3 ounces that we already had. So the package has a total of 35 ounces. All right, so now we've got our package in the right units, okay, to go ahead and find the postage. All right, so now for the first ounce, we know, we're going to break this down. We know we've got 1 ounce. That's 44 cents. All right, and that was in the problem statement. All right, that's taken care of. But then we also have 34 ounces at 17 cents per ounce. Okay, no problem. So let me switch it up just a little bit. So we're going to come over here. We're going to say, okay, we got 44 cents plus 34 ounces. Now still do your dimensional analysis times. We're going from ounces to cents per ounce. So 0.17 per ounce. Okay. The ounces cancel. All right. You just take your calculator and you can type what you see. All right. 0.44 plus 34 times 0.17. You know your units cancel, so this will end up being $6.22 to mail this package. Okay. Real simple. Okay, and then I think that may be it. No, one more. This will be the, and I'll break it after this. So this will be the end of part 1, this last example. So Alan is making chili. He's using a recipe that makes 24 cups of chili. He has 2 options in terms of what to use to make his chili in. He has a 5-quart pot and a 2-gallon pot. All right, which of the pots will fit the chili? Okay, so what we're going to do, we're going to compare. So we'll split this sheet up. Okay, so 5 quarts. All right, now his chili, they tell me 24 cups. So I'm gonna break that quarts down and see how many cups are actually, or how many cups are in 5 quarts. All right, so again, now you can use Siri, you can use Alexa, you can do it this way, you can do it by hand, but either way, whatever the case may be, it's still doing the dimensional or unit analysis. Okay, so 5 quarts, I know that 2 pints equals 1 quart. Okay. And I also know, now notice that didn't get me down to cups, so I had to use another conversion factor. Okay, so then I know that 1 pint is 2 cups. And let's put a C, 2 cups. All right, so now I went from quarts down to pints, and I went from pints down to cups. And we're going to cancel a lot of these units out. Pints cancel, quarts cancel. We're down to to cups, I'm sorry. All right, so 5 times 2 times 2. All right, so that 5-quart pot will only hold at the most 20 cups. Okay, that's less than 24 cups. Because that's what we need. So we can't use the 5-quart pot. So we're gonna put an X there. We can't use that. All right, so then we're gonna come over here and let's compare it to the 2-gallon pot. All right, so we know that 2 gallons. All right, so 1 gallon, and we're just going to stack these conversion factors. So 1 gallon is 4 quarts. And then I know that 1 quart is 2 pints. And then I know that 1 pint is 2 cups. All right, so we clean this up. All right, so now go through and cancel out your units and make sure you end up in cups. Okay, so units should be on the diagonal and they should be getting canceled out. All right, gallons cancel, quarts cancel, pints cancel. All right, and if you messed up one of those conversions, that's why you write it out by hand. All right, so now we're going to multiply. We're going to multiply 2 times 4 times 2 times 2. So this will be, let's write it out, 2 times 4 times 2 times 2, and then we're going to just keep the cups, okay? So this is 8 times 2 times 2. Bring that down, so that'll be 16 times 2. Now, y'all don't have to do all this, okay? You can just multiply directly. I'm just showing you. Just keep breaking it down. So we're going to end up with, let's see if I can scroll up. Ooh, just a little bit. Nope. So we're going to end up with 32 cups. Okay. Boom. All right. So we know that the 2-gallon pot will indeed hold the 24 cups of chili that Alan's using for this particular recipe. All right, so that's part 1, okay? And I'm gonna come right back and do part 2. So let's just stay tuned, and I'll do part 2 momentarily.